Hey everyone, my name is Lauren and today I'm going to be explaining chaos theory. You might have heard of this phrase before. A butterfly flaps its wings in New Mexico and a hurricane is caused in China. That saying comes from the concept of chaos theory, which is that small causes can have much larger, more drastic effects, also referred to as sensitive dependence on initial conditions. It is a mathematical concept about complex dynamical systems and nonlinear functions. That is, systems and functions with so many variables and components, all of which are dependent on one another. While it may sound complicated, you find these kinds of systems everywhere, especially in nature, which is why the weather is so hard to predict. Because the weather is a complex systematic pattern, it is determined by so many factors, and any slightest change in the original parameters will end up changing the complex system, in this case the weather. In the butterfly example, the butterfly flapping its wings changes the waves of particles moving in the air, which is an initial condition. It is impossible to perfectly predict any future event. A physicist named Werner Heisenberg developed the uncertainty principle, stating that we cannot know the condition of anything in full detail. This means it is impossible to know all the factors that go into a complex system, which is what makes it so chaotic. Edward Lorenz, who developed chaos theory, came up with the Lorentz attractor, the first strange attractor. An attractor is the state of equilibrium a complex system settles into after running through various cycles. A strange attractor does not settle and has a fractal structure. Fractals are the pictures of dynamic systems, the pictures of chaos. They are formed by repeating a process in an infinite feedback loop. In the Lorentz attractor, two almost, but not quite, identical points are put side by side. They start out on the same path, but because they have slightly different initial conditions, their paths start diverging, creating this figure-8 loop, representing different outcomes. To put it simply, a bunch of factors cause one huge event, and any change in one of those factors will change the event. Here is a real-life example. Say someone wakes up late, so they rush out the door to catch the bus. While doing so, they drop money that they were going to use to buy food out of their bag. This is where the paths would diverge on the model. They realize they don't have money and don't get food for the day. That day, their teacher gives them a pop quiz worth a lot of their grade. Because their brain doesn't have any nourishment, they do poorly and get a bad grade. It ends up messing up their GPA, which in turn leads to much greater consequences. But you see, every action makes an impact on the world, not just a single person's life. What about the money they dropped? Say someone picks it up. They use it to buy food instead. Where they are, they realize there is no trash can, so they litter. Their trash blows into the ocean, which kills marine life and ends up affecting the whole ecosystem. Remember that all of this started with someone waking up late. However, so many factors went into all the events. Change any of the factors, and the end result will probably not be the same. Any tiny action is a factor in a far bigger reaction.